Hello and welcome to the next episode of Klingberg Wing Mark II Development. I'm Raul Klingberg, your host. I have a special episode here today because I'm not covering the construction or modifications of the glider or any flights like that. But I felt I'd take some time to make a special video on the second chance uh, deployment system for emergency parachutes or reserves, if you prefer. Um, and the reason I'm doing this is because this unit was loaned to me by a special friend, Daryl Robbins, who's a well-known pilot in the San Francisco area. Um, it was very generous that he provided this. Uh, we were looking at ways of incorporating this into my glider to deploy a reserve in case of emergency. And I looked at it a lot. I made a few minor modifications, and we looked at a parachute to go with it. Went round and round for about a year, actually. Um, and really, I didn't like any of the solutions. So I went, as you know, I went off and bought a fairly spendy ballistic type system that's air driven. This is also air driven. But this is a system that drags the parachute out of a container, and my new system is something that shoots the parachute out of the container, and it's packed up much smaller. Not much difference in weight. But as Daryl said, he says, I'm glad you bought a good system for your glider, which is true. I mean, it's a critical component. But Daryl thought it would be interesting and nice if, while I had this thing apart, that I documented it, because as much as we look around, we don't seem to be able to find a set of instructions for maintaining or recharging the system. And lots of people have them. Uh, and they're really well built, and they've probably lasted a long, long time. Most of them are probably in really good shape. But if somebody's got one that's been sitting on the shelf for a number of years or has been in use for a number of years, and it, it's probably a good idea to take them apart occasionally and service them and make sure that they're operating properly. But there's no documentation out there on how to do that. So here you are with a video that will document how this system is set up and how it works and how you might be able to maintain your own system. And I'll assure you that the taking apart and maintaining, pretty easy. Putting it back together, little tricky. Um, okay, so let's just review what the system consists of first. Comes in a nice container like this. This line here attaches to a riser from your parachute usually at the crown of the parachute. That's going to pull the parachute out of a deployment bag. Um, Whether or not this is strong enough to pull out the entire parachute in its deployment bag, I'm uncertain about that. Haven't had a chance to test it. But I think mostly these were designed to go on harnesses and so forth, where this is connected to the crown of the parachute. The deployment bag stays on the harness, and this drags the parachute out of that bag. There are some drawbacks to that, in that if you have an unfortunate circumstance where your wings are folded on a hang glider in such a way that the chute would be dragged through any of the remaining structure, and that could just completely ruin the deployment of the chute. What you like to do is you like to get the chute away from the glider before it opens. On my new system, it shoots at about 15 feet before it begins deployment of the parachute, which is a good thing. So that's its minor drawback. But other than that, it looks like a pretty cool system. I've seen a deployment of one of these once. Not personal. There's video on YouTube of it happening. It happened to a friend of mine, Steve Morris, accidentally. Pulled a cable to deploy, and you hear this, and you hear clank clank as the rocket falls back on the ground. Steve no longer uses the unit, but I'm going to put a link to that video in the description so you can go see what it looks like when one of these things deploys. In that video, it pulled everything out far enough so that the shroud lines for the parachute were deployed. I'm not certain it would have been far enough away from the glider if there was any kind of structural problems. So pluses and minuses, no system is perfect. Okay, so line to attach to your parachute, It's in its container here, which you can Velcro or bolt or sew it to your harness or wherever you want to put it. Sorry, Daryl, but I put 4 grommets in here where I was going to bolt them into my glider, and unfortunately can't undo that. And then at this end, a little red cover. I like how they have it red so that you know, oh, you're futzing around with stuff where there could be a hazard. And we'll see why that is here in a minute. But at this end, we see the pressure gauge, which will tell you what's currently in the cylinder, and usually sits about 3,000 psi. These are charged, refilled or charged off of scuba tanks, which are generally at 3,000 psi, and it's done with this yoke device here, which we'll talk about in a minute. Okay, so and when it's released, and I'm going to talk about the release handle later. I'll talk a little bit about the mechanism here, but the handle we'll discuss later. It's just a handle that you pull on. It's got a little webbing strap connector here as a safety. You know, when you're not in flight, this is clipped together so you can't accidentally hit the handle and deploy the system. So, handle is deployed. You pull out a pin. There's a little cotter pin here. It goes in here. I'll show you how later. And when that cotter pin goes out, it releases the internal mechanism that shoots the rocket. Now let's take a look at the guts of this. There's a little Allen cap screw here on the side that goes through 2 internal components and holds them all together and aligned. So I'm going to undo that and I'm going to pull it out of the sleeve here. Don't worry, there's no air in the cylinder right now, so we won't see any accidental deployments in the garage, because that's never fun. So there's the little cap screw. And I'm going to pull it apart in 2 directions here. So here's the rocket itself right here. And this uses what appears to be, to me, a standard gas container. You know, you can put air in here, some other things. It says, danger, high pressure, no kidding. Aluminum alloy cylinder. And this is from Parker, which is a famous maker of cylinders for storing gases. It says, Cliff Impact Division, East Lake, Ohio. So if they're still in business, you can probably reach out to them and get another cylinder if you wanted or needed. And then it looks like they machined and anodized a custom aluminum nose cone to cut down on the drag a little bit on the way out. This end of the cylinder up to here, it appears to be stock. And what does it say here? There's a bunch of codes here that I don't know what they mean. But if you call Parker or their distributor, that'll probably tell you the month of manufacture and some other factors. So up to here, the cylinder looks to just be a stock item, and then the shroud pull lines are connected on here quite well. They have sewn up the pull line here in kind of a yoke that goes all the way around. And you get an even pull here, either side, and the nozzle itself is screwed in to the end of the cylinder. I'm guessing. I don't see any welds here. I see a little O-ring there maybe, and I'm hesitant to take this apart. That'd probably be a bad plan. But there's a nice steel nozzle here. There's a groove machined around that neck of the nozzle. And then there's a blue anodized insert here. And why they have the blue anodized insert, I do not know. Let's see if I look inside. Oh, that's part of the nozzle construction. So they did the nozzle as a 2-parter. Okay, so it's just a standard rocket nozzle in here. It's probably a 30-60 convergence, divergence nozzle, most likely. And the interesting part, or important part about this is the groove that goes around here. Okay, and that is a part of the release mechanism. There's a series of ball bearings that go in here like this. And you think, how could I ever get this assembled with these loose ball bearings? If you ever deploy one, probably lose all of the ball bearings. You might save some, but I wouldn't ever reuse the ball bearings. Anytime this is shot or disassembled, I put in all new ball bearings, and I'll just let that guy roll away. When the ball bearings are inserted, they're put in with silicone grease. Any high quality silicone grease probably do the job. Stock stuff, very inexpensive. And you can fill the groove with this grease. these ball bearings are. I measured them, we double checked, we bought these ball bearings and fitted them in, and they were perfect. They are 3/16 of an inch in diameter, and these happen to be grade 25. You get 150 in a bag for like $5, something like that. These are chrome steel ball bearings. So that's, here, I'll lit up a little closer. These are the ball bearings that you would need to service the unit. So you need ball bearings, you need the grease to service it at a minimum. Okay, so that's that part. Now the other part here. So, oh, we could count the holes here. Here's the whole base of the unit. Goes in here just like this, okay? And these holes that are in this unit line up with that groove that's there. So, I guess if you're fiddly enough, you could put enough lithium or silicone grease in here and put the ball bearing in from the inside and have it just sit in there with grease. Now I'm going to show you the spring deployment system here in a second. I guess if you were really creative, you could find a way to hold that spring in place around the outside and then put the balls in from the inside. But how my buddy Bob and I did it was we put the balls, how do we do it? We put it together like this, and then we dropped a ball in each hole. And there was plenty of grease to hold everything in place. And you get this lined up with a groove like this, and let's see, let's grab a ball here and drop her in. Come on, over here. I think this is how we did it, if I remember correctly. Yeah, that's how we did it. So we put the silicone grease in there, got these parts lined up, and dropped the balls in. And the balls, because of their size, they're in this groove, they go in this hole, nothing can come apart. It can't come up out of the groove because there's going to be this steel spring here around the outside. So the balls are held in with that spring like this. They sit in this groove and nothing can come apart. I think Daryl had this for years, charged up, and it held its charge for, I don't know, Daryl would be able to tell us, but many years. I think it was just ever so slightly below 3,000 PSI when we took it apart. And then after we put it back together, we charged it up to like 500 PSI or something like that, just to make sure we had it correct. Now for the tricky bits. So you get this guy on here, you get your grease in there, and you drop in your ball bearings, and then you have to put this spring in place. And this, they must have had a special tool in the factory to do these, is what Bob and I concluded, because it probably took Bob and I an hour or more to put this spring back in place. And that's because we had to build a tool to do it first. There is a very shallow groove on the surface here. I don't know if you can see it, but in the surface right there, there's a little groove. And in that groove goes this tab that's on one end of the spring. And it goes just like this, there. Now, I'm hooked in to that slot, right? And then you would think that, hey, I can wrap this thing. I just put that back in the groove, and I'm going to wrap the spring around and get this all reset. Easier said than done. That groove is super shallow. And I suspect that the reason they made it so shallow is to not take any chances about a hang fire, where you release it and this thing's just a little too tight, a little too deep in a groove, and it won't come out, and then you're really screwed. So they made it as shallow as they could, and they probably built a nice solid steel and aluminum tool to put all this stuff in and wrap that spring. So Bob and I created this tool, which is now broken. We scammed this together in a few minutes, such that there is on the end here a little aluminum plate bonded on the end that it goes around with the spring, and you can compress it on here, and that aluminum plate, and you see how it's cut this way here. This one's vertical, this one's at a big angle. It's got an aluminum plate here, and that aluminum plate is designed to engage the other end of the spring so that you can pull it around like this and wrap it, right? And the other side holds pressure down, and what it's doing is holding pressure on the little tab that's here to keep it from coming out of the slot. We could probably make a much better one of these. This is what you can build in 15 minutes and glue it together and all that other stuff, and then it breaks off. But once once this finally broke in half, then Bob was able to use it as two parts in his hands to hold it together tight enough to wrap this around. Now, what did the real one look like? Haven't a clue. But I think any good builder would understand the concept here, that you need to be able to squeeze this together and hold that spring as tight as possible in that little slot while you have this part that's pulling this part of the spring around and wrapping it. And then you got the other guy holding it all in place, and eventually you wrap it around all the way. I'm sure many engineers out there will find a much better tool for wrapping this around, but it has to wrap around. You have to keep this little tab in the slot, it has to stay in the slot, and you wrap it around until this tab on this end, which actually has a U shape to it, a little U shape, and you wrap it around until it lines up with, there's a hole in here, a little round hole, and there's a hole on the other side. So when it's finally wrapped all the way, this sits in here just like this, okay? And then, while you're holding it all together with a tool, and don't let anything spring loose, which only took Bob and I maybe 20 or 30 tries, you can take it's just a big cotter key, and you shove it through that first hole back here, and into the spring that's in here. I can't even do it without tension on it. So finally, you went away, you came back, I got it in here. Now this is probably the reason why the original owner's manual probably says it has to be returned to the factory for recharging, for servicing or recharging. I wouldn't blame them if they put that in the instructions. And can you do it reverse? Shove it in underneath? No, it's too tight. When this spring is all the way tight, the leaves of the spring are very tight together, and because the little tab that's on the end, there's no way you can really, I can get it around once, might be able to get it around twice, but you're never going to get it all the way because of this little tab that's on the end. So it has to be wrapped from the outside. But you see the basics of this, so that this pin is holding the end of the spring in place. And it can't unwind because there's tension on it, and this pin is holding it all in place. And the deployment handle has a grommet in it. This pin goes through that grommet first and then slides in and locks these parts in place. And when you pull the deployment handle, it just literally pulls this pin out like this, and boom, it springs apart. And because of the tremendous pressure that's in here, the 3,000 PSI, and the fact that this groove, the groove that the ball bearings are sitting in, is tapered. Both sides are tapered. So there's quite a bit of outward pressure on those balls, trying to push them out. And they can't get out because this spring is wrapped around them. But as soon as you release that spring, well, the pressure that's pushing the cylinder forward puts a load on the ball bearings, on the sides of them, but at an angle. So that causes a outward force to occur on those ball bearings. And I gotta admit, this is a very simple, straightforward, excellent piece of engineering. It is, in my mind, fail-safe. You release the spring, the balls are going out instantly because there's 3,000 PSI working away at it. And if the balls are not rusted, and if they're well greased, they're not going to stick to anything. Boom, and out you go. Now, we didn't deploy this when I got it. We decided to just drain the air out of it normally. But I would say if you have one of these that you think needs servicing, or you would like to empty it and recharge it, I would say just to check everything, go out to your local empty field where nobody's around and go ahead and shoot the thing off. They're very rugged. I don't think you could possibly hurt anything, even if this landed on concrete. Stay away from the houses because you know this thing probably has a homing device in it for Windows. So I would say the most efficient way to really give it a go is to fire it and make sure that it actually works before you go on to servicing. And I would say when you're servicing, before you start fiddling around with the balls and grease and all that other stuff, and build yourself a little tool for doing this job. You probably make 3 or 4 different ones until you have fully figured out how to rewrap that spring that works for you. Then you can get involved with putting the balls in and wrapping around here. So when it's done, you have this unit, which fits on the end here like this. It'll be on here like this. The spring will be wrapped around here. This spring will be wrapped around, and it'll have the pin in it. The pin will go all the way through like this, holding it all together. And then it would just stay just like that. Everything's fine. But in order to make this a usable product, they had to put it into a container so you could deploy it. And inside here is an aluminum sleeve. Before this is reassembled, this has got to go on here and go on just like that. And you would slide this up on the cylinder. There we go. Now we're talking. This is on the end. Got the spring wrapped. The pin's in there so they can't be fired. And then this has to be slid back. Pull the ropes through as you go. And you slide this back. Pull the ropes while you do this, roll. Until we're clear. And as you get here, you can slide it on to here and rotate it around until it lines up with the screw hole that's in here, right there. So this is what it looks like when it's fully assembled. And I would say when you do this, make sure that this release pin is secured, it's safetied off. A bunch of tape over the top of it, some little securing thing that goes through this and gets latched down so you can't possibly accidentally knock this loose, because that'd be a bad day. You wouldn't want to have that happen. So once this is all reassembled with a pin sticking out the end, then you can reinsert it into its container and drop this guy in and insert the whole thing in. Get this holes, there's a couple of holes there, lined up with the grommet that's on the side here, and then you drop your screw back in. And then the whole thing is set up and ready to be fired. Now, all that said, you can't really fire it again until you fill it up. So how do you fill this thing? Well, they have a yoke here that is a pretty typical scuba diving tank yoke. This is designed, this part goes over the fitting that's on the end of the scuba tank, and you can screw this down until it's tight to the little receiving cup here, and you are sealed off to the scuba tank. And then there's a little bleed valve on the side here, which you would normally have closed. And this screws in to the end down here. In fact, you can actually screw it in without, when this is on the tank, this is free to rotate so that you can screw it in place. You can put this on the tank first. The yoke goes on the tank first, and then you can screw it onto here, just like that. There you go. And then then you have to have this open so that you can fill. Now what's on the side here, what is this on the side? Is normally when this is ready to use, when it's filled up and ready to use, this is removed. You got it filled up, it's ready to use. The gauge says 3,000 psi, you're ready to go. And this is removed. So there's a valving situation here that occurs. Before you remove it, you close this off, such that this is then all sealed off, just like this. So if you didn't want to fire it, you have to pull this bleed bolt on the side. And if I remember correctly, as we open this, yeah, it says 3,000 here, which is indicating the pressure that's on the inside. And there's a little hole drilled in the side here. So this is a bleed nut and bolt. So as you crack this open, the air is going to come out the bleed hole. And that will drain the system safely. So if you don't want to fire your unit, you can just bleed off the air this way, which is what I think Bob and I did. So there you go. The fittings in here, the threads in here, and this fitting. If you went to Amazon and bought a yoke for a scuba tank, it's the same thing that they use for paintball guns, to recharge paintball guns, except this is a very unique thread here. It's sealed off with a little O-ring, and this thread is very difficult to find. I went to a air fitting supplier that has thousands of fittings, and I still didn't find this one. This is an original unit. You can tell by the blue anodizing. And with all of the stuff that was available for paint guns, I never could find the correct fitting to go on the end. I don't know if I have a spare in here or not of the wrong ones, but I bought 3 or 4 different ones because on the paintball gun stuff, this side that you'd have to thread it into is one side, and then the size that fits in here is another size, and I never found a fitting that had both of them on one fitting. In fact, I never found a fitting where I could put 2 fittings together and match the threads. So if you don't have an original yoke, it will be a challenge to find something that fits this properly and fits a aftermarket yoke and fits a scuba tank to get it refilled. And that's a darn shame. Unless you got a little machine shop available and you can cut your own threads on that fitting and make your own fitting to adapter to go between here and one of these aftermarket units for the paintball world. So that's the whole deal. And let's see, what else can I tell you about it? Other than, I'll go back and repeat, really well built. These are stout. It is not lightweight, which was one of my chagrins. It is not easy to reassemble, but I would say that this is probably a really reliable unit. I can't imagine a way that this would fail if it's properly maintained. And when you're not flying, this is not something to leave out in your truck or car. This is something that should come in indoors and be stored in a reasonable environment. I hope you found this helpful and enlightening. And Daryl, once again, thanks for loaning this to me. Didn't use it, but learned a lot in the process. And I hope this video helps out other people with their system. And right here at the end, let me, be a couple days later, I'm going to turn you around and I'm going to show you how the release handle is set up. Okay, so when you get ready to recharge your system, you would open this up, so the whole thing's assembled and ready to go, but empty. You open this up and you take your yoke. I think I showed this earlier. Yoke goes over the scuba tank. You'll need a scuba tank with a flat face interface on it. There's several different types of valves on scuba tanks, and you got to make sure that the interface on the scuba tank matches your yoke. Okay, and then you would screw this in here, just like this. I'm not going to screw it all the way in. Now you get that screwed all the way in, and then you can hook it up to the scuba tank and do the charging. So what you want to do for the charging, you want to make sure that your bleed here is closed off solid, and you want to make sure that this screw right here on the side is open. Okay, so once you have this screwed all the way in at this joint right here, then you can attach it to your scuba tank, and then open up the scuba tank and begin to fill your system. You'll hear a noise come out of this area right here. That's a check valve that makes sure that the air goes in one way and not out the other. And it'll go boop, 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 and that'll slow up as this gets full. Boop, boop. And eventually it stops, and then you're as full as you're going to get. You'll never achieve the exact same pressure that you started out with in the scuba tank because you're using up some of the air. Now, once that's done, you can, before you take this off the scuba tank, you can open this valve here on the side, and that bleeds off the excess air that's in between. And that's once your scuba tank is turned off. So when you're ready to detach from the scuba tank, you turn the scuba tank off, seal that off, open this valve, bleed out the air that's in between here, and then you're ready to unscrew it from the rocket portion here. And then you would take this off the scuba tank. Okay. you want to make sure that you bleed it off before you pull this off the scuba tank, because you don't want high pressure air. You don't want high pressure air in the middle here. So while it's still on the scuba tank off, bleed the air, then you can detach everything. So you'll see what I couldn't show you before in the earlier video. You'll see here that you have the deployment handle, and it comes around the corner here, and the pin that gets pulled is right here. It goes through the grommet that's in the end of the handle. What you can see here is the cotter pin and the deployment handle, and there's a little grommet here, and when you pull the deployment handle, that pulls the pin out and deploys the system. Very, very simple, straightforward. Before you can do that, of course, you have to release the safety here, which is just a click lock webbing connector, little plastic part. And I modified this one to have the remove before flight tag on it, which I think is a great idea. When you're flying, this is not inserted in here. It will be loose. If it's inserted in here, you won't be able to pull this handle and you're screwed then. So make sure that when you take out your remove before flight tag, that you do not put this buckle back together. It stays open while you're in flight. And let's see, I don't think I need to demonstrate this for you, but this release handle, which is attached with Velcro here, runs up to here. When the buckle is open, very easy to activate. When you pull it, it puts a load on this part of the handle going out this way, which causes the Velcro to peel back, and it pulls the pin out. And it's very easy to pull, very easy to deploy, which is why we're not going to mess with it here, because this system is charged up and ready to go. We are showing 2,600 pounds, 2,600 pounds of pressure in here. I've seen them as high as 2,800. I don't think you get the full 3,000. Even though the scuba tank might be loaded to 3,000, you won't get that in here, but 2,500 is plenty. And then once you're all ready to go, you put the safety cover back on here, because you don't want anything to accidentally run into that deployment pin. And you would open this up, remove your remove before flight tag thing, leave the buckle open, and she's ready to use, ready to go fly. And this one itself is ready for use. So you see overall that this is a really well built system, essentially foolproof, so long as you remember to leave that buckle open when you go fly and make sure nobody bumps into it. It's got to be in some place safe where nothing can run into that little buckle. Maybe the best bet, somebody might want to take the risk of modifying this such that this end of the buckle, the one that's closest to the handle, would come back here and secure to the handle itself, so it's not flopping around and you can't catch it on anything, yet it's not connected to the other one, and that way the system would be ready to go. But the original handle that I saw didn't have that on it, and it might be an extra little safety thing that you might want to consider and modify your own system, so that maybe there's just a little piece of Velcro here and it sticks to the handle, and that way it's not flopping around and possibly catching on something. We've got, with all of these systems like this, you have to be extra careful, because when they fire, there's a lot of force involved. And we don't want to be in the way of the pointy end if it fires. And we don't want it to fire accidentally in flight. So as you can see, overall, really nice system. These are super well built, last multiple generations. I mean, you could hand this down to the next generation of paraglider or hang glider pilots. So if you have one of these, cherish it, hold on to it, make sure it doesn't get dented or dinged, and it should last forever. And I hope that my viewers out there have found this useful. I'm going to send a copy of this video over to Ken DeRusi, who is posting a lot of historical hang glider and paraglider footage. And in there he has a video from the second Chantz people, from the people that did this system originally, and they show a lot of interesting deployments and other facts about the system, but nowhere have I found a set of instructions or anything about maintenance or how the system's actually built, and that's why I made this video. My buddy Daryl was very generous to loan this to me for a while, and I told him that in exchange I would shoot photos and do a video on how to maintain the system. so that perhaps those of you out there that still have one of these things and it's charged up and you'd like to bleed it off and take it apart and check for rust and so forth, make sure it's all in good shape, put it all back together, you now have some video and other information that you can gather up to take care of your system. So there we go. As I always say, fly safe. Bye for now. Hello and welcome back. It's been, a couple of weeks, maybe 3, since I shot the first part of this video. And now that I have the deployment handle available, I thought I'd come back and show you that and make a correction. First, let's talk about the correction. In the early part of the video, I talk about charging up the system. And I had it disassembled at that point, partially disassembled out of this launcher tube. I realized it's pretty bad advice because you really have to have the whole thing secured with a safety pin in, this latch done before you charge the system up. Otherwise, it's just simply not safe. It's too easy to trigger it. So let me amend that by saying, do not charge your system until it's in this state where it's all assembled and essentially ready to use but empty.